So hey, I'm Shrisha. I'm currently an engineer at Slack.
Mhm.
And I'm doing mock interviews for fun. There's no specific reason. So yep, that's a bit about me.
Mm. Hi, my name is Mincy Han. I'm currently a master student and just looking for like an internship.
Okay, cool.
I, I'm not sure looking just could kind of fun things, but I have to do so. Yeah.
Yep. Oh
So
yeah,
yeah,
like
yeah.
mock interviews are definitely super helpful. So yep, they like actual interviews get a lot easier. Like after you do mock interviews. So yeah, keep
Hmm.
continue doing them. Cool.
Yeah, yeah. Cool. I think you can go first.
Sure.
It's like yeah.
Yeah, this should be a question for me. Okay. So before we start, should we maybe cap our time limit to maybe 30 minutes for each of us? Is that reasonable?
Sounds good.
Okay.
So I will, if you during the time, if you just want any hint or something, you can just ask me, or I will ask you, kind of things.
Yep.
So yeah,
Awesome.
please let me know.
Okay. Yeah. Cool. So this is a sorted array of distinct integers shifted to the left by an unknown offset, and you don't have the pre-shifted copy of it. For instance, sequence 3 becomes 3, 4, right? Yeah, shifted twice to the left. Okay. Um, Given the shift array and an integer num, implement a function search that finds and returns the index of num and shift. If num isn't in shift, return -1. Assume that the offset can be between 0 and length -1. Okay, so there's definitely some sort of shifting that was done. Um,
Hmm.
okay, and it's sorted, and it's the number may or may not exist, and if it doesn't exist, we return -1. Um,
Hmm.
so yeah, obviously the kind of brute force trivial approach would be to do a linear search, but since this is sorted, we can do like a modified binary search, right? And that'll we should be able to get the answer that way. So I want to paste this example down below. And so in this case, if we search for number two, so kind of taking the binary search approach of, let's say we do left equals 0, right equals, we've got 6 elements, so right would be 5. And then mid would be 2. So we look at
Hmm.
17. 17 doesn't equal 2. And then we got to decide to either move left or right. Um, so there could be a few different cases, right? In this case, we've got 9, 17 decreasing. Um, so we know the shift, like the first element we know is on the right. Um, so in this case, we could do something like if left of, I'm kind of walking you through my algorithm. So if we know array of left is, and these are all unique, right? So we can simply do if array of left is greater than array of mid. Um, oh, sorry, this is shift R, but I'll change it to just ARR. Um, and if we know our, um, I guess there could be two cases. Case one could be my num, if num greater than array of left. I'm gonna check on my left half, so I'll make my right equals mid minus 1. Um, or else my left would be equal to mid plus 1. Right? Because in this case, this is telling me, yeah, like that my left is lower than my mid and my number is between that range. So, and my number is greater than left. So my right would be, I would look on my left side of the portion, left side of mid, and so I would do this. Or else I'm gonna look on the right half. Um, there's also another case where, so what's the other case? The other case is pretty much um left is greater than right. So that would be an example of that would be, say, 17,235 and then 12,17, right? Or 12, right? 912. In this case, say the number I'm looking for instead of 2 is, I'm looking for something like 12, and this is 4, and then I know that 17 is greater than 4. Um, and 17 is greater than 4, but there could be a possibility. So in that case, I could probably do if num lesser than array of right, then I should move my left to mid plus 1. Else I'll do right equals mid plus 1. Um, yeah. In this case, if I was looking for, so let's say this is one edge case, this is one test case, and this is the other one. Searching for 12. Okay, if this was my kind of my algorithm, I can I'll let it be. I can't do a multi-line comment on PAM, so I'll just let it be. So let's consider use test case 1 on line 6. Submits 17. 17 is obviously all of this would be if mid equals to return mid. Like I'll have the typical while loop if left and right conditions, and this logic would be inside that. The 17 is not equal to 2. I'm sorry, I didn't mean to do this. I meant to do. In this case, is left less than mid? No. So I'd go into the else condition, and I'm gonna check that my num is less than 5. So I'm gonna go into the right half, right? So this would be my range, and then my mid would be 4. That's not equal, and my array of left is lesser than mid, and gotta check my num greater than, oh, I should do greater than or equal to, and same over here, less than or equal to. So right equals mid minus 1. So this would be my new new left and right. Mid would be this index, and I would return the answer. And in this case, I would get 4. 12 is greater than 4, so we would go into if left greater than mid. No, so we'd go into the else condition, and we would do is is num greater than, sorry, lesser than or equal to right. It is, because 12 equals 12. We'll increment left, and we get all of this. Then we get mid equals 9. And then we do is array of left lesser than mid? Yes. And then is num greater, oh, this would fail. So we've got 9 greater than 5. If num greater than or equal to, is greater, and I'm gonna do right equals mid minus 1, which I shouldn't be doing. Should I have an additional check? So at any point there would be two cases, right? I feel I could maybe make this like this logic simpler. Yeah, maybe I could simply do something like if num greater than array of mid and array of right. No, that wouldn't give us. I was gonna say an array of right is greater than array of mid. We could then go check on the right hand side, but I don't think that's true because I guess I could do this. Sorry, these modified binaries are always tricky.
I got a question. I just not understanding for like your solution is I know you first find the middle one, like the 17, and you just check if the left, if you check you will go left side or go right side. Is that your thought?
Yeah.
But if you have already find the largest one, is it's so hard to define is go left or go right because everyone is smaller than the middle one. Like if just use the first one as example, like the middle one is the 17, right?
Mm-hmm.
But when you find the 17, you go left or go right?
Yeah.
Because
Like, are you suggesting I look just for the next number? Like, so in this case, if I know the next number is lesser than 17, I know that's where the shift happened, and then I can.
yeah, I'm not sure is that possible, but to me, I would say I will find the like like to find the smallest one first to
Mhm.
check like I will go 0 or go this index or go this one. Because if you didn't find the smallest or the largest, it's so hard to check like which side is you're looking for.
Yeah. Um, yeah, I think that's true. Um, could I maybe get 5 more minutes on uh,
Yeah,
continuing?
yeah,
I just wanna, I
that's
think,
fine.
yeah, I think I'm close on the algorithm, but give me there's two cases, right? Got my notebook. So there's always two cases. You're either where you are, it's either rising, um, like increasing numbers, or oops, I didn't mean to do that. So it's either increasing or you're at the peak and then it's falling, or yeah, it's always increasing and then this peak, or it's at the peak, then dropping. Um, you're at this point. In this case, you're saying if left is lesser than mid. I think that's good. So if left is lesser than mid, and okay, let's do this. And I've got num greater than. Okay, cool. So let me do this. So if I can do. Then you go right, or else you go like the right half. And in this case, um, oops. Cool. I think I've got something. So what I would do is, um, I would do simply do if num is lesser than array of mid, um, then what I'm gonna check is if array of left is greater than or equal to num, then I'm just gonna look in the left half, right, right, equals width minus one. Else I'm gonna look on the right half. Um, and the other case is when num is greater than the mid, right? And in this case, I'll do if array of right is greater than or equal to num, then I'll look in the right half. Else I'm gonna look on the left half. And I didn't mean to do this. I meant to do equals mid plus one. I think this would work. I know we're kind of short on time, so do you mind if I write out the actual code? I could reuse all of this, just add this within a while loop, and then I can run a few tests.
Yeah, yeah, just go ahead.
So let's do equals 0 and then of array minus 1, and I'll do while left greater than or equal to right, mid equals left plus right by 2, and if not found, return minus 1. I just want to make sure this is okay. Indent this. I am happy to try this out. So let me do print. Um, line 12.
Uh, yeah. You just need to change the position of
Ah,
equal or
sorry.
greater.
Yep. Okay, that's not right. So I want to make sure I didn't mess up any. Left plus right by 2 equals num return mid. This is num lesser than array of mid. And sorry. That's what I meant to do. Then right. Then all else increase. In this case, right. Yeah, this is what I meant to do. Index 3. Right. Um, so modified binary searches, it always hits you at a moment and then it works. So let's try some edge cases, right? Let's try um, first character, or sorry, first index, last index. And let's also do 12. Um, and 2. Oh, we've done 2 already. Slightly different example. Maybe let's do, yeah, let's do this. Also do 5. Cool. Sorry. Yeah, 15. That should return -1 and also do 5. Okay, so 3, 0. 5. Yeah. 12 is first index. 17 is 0th index. 15 is -1. 5 is index 3. Yep. Yeah, I'm pretty confident about this. I can run the test suite. Should I go ahead?
Yeah, definitely.
Yep. Um,
Ooh, you made
yeah.
it.
Um, yeah, so I can talk about time space complexity. Time complexity is log n. We're pretty much doing a modified binary search. So at any point, we reduce our search space to half of the
Mhm.
current array. Um, and then space complexity would be constant because you only got these variables. Um, yep.
Yeah. I think you good. Everything's going smoothly.
Cool. Awesome. Cool. We can do feedback at the end. I can swap roles.
Yeah. Okay. So my question is getting a different number given array of a unique non-negative integer. Implement a function that finds the smallest non-negative integer that is not in the array. Even if your program requires a line restriction, assume that the maximum value an integer can have blah, 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 blah. Your algorithm should be efficient both from time and so first a case where you're not allowed to modify the input, not allowed to modify the input. If successful and still have time, see you can come up with an area in input space. When you are not allowed to modify the input.
So I maybe
Uh, uh, uh,
So let's focus on, I guess you can't see. Let me post the question in the editor. And then maybe, so let's focus on this part first. So let's focus on this part. Let's try to get to a solution and then see if we can optimize it.
Mm-hmm.
So what it's saying is, yeah, you've got non-negative, distinct integers, right? Unique integers, and
Mm-hmm.
we pretty much have to return the first smallest non-negative integer that's in the array. So in this case, 0, 1, 2, 3, 4 is the next. Four is the smallest
Mm-hmm.
non-negative integer, right? Because 0, 1, 2, 3 is
Mm-hmm.
taken. If we had, if our input was 5,
Uh-huh.
then our answer would be 3.
Sorry.
Yeah. Or let's say if we had 1, 2, 3, our answer would be 0 because 0 is non-negative, right? Um,
Mm-hmm.
and what else? Yeah, few edge cases to think about. Our maximum value is 2 power 23, 31 minus 1. And so we would have to return undefined. And same for, yeah, pretty much that. That's the only edge case, right?
Mm-hmm. Yeah, yeah, I think I understand.
I can comment all of them. And so is Python okay? Because it's set to Python right now.
So, cause I cannot just sort the input, so I cannot um
Oh, you can sort the input.
cause 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 it will say not allowed to modify the input.
Okay, okay.
Uh-huh. So first if the array could be sorted, it could be easier because I can just get into the iteration and just check if the index equal to the element. So
Yeah.
the first not equal is definitely the answer because it's not allowed. So I need to try to find another way to. Um, so I have a thought like can maybe I can use like the exclusive or let me first check all the number is unique or is oh okay, so it's a unique. Okay, I will put my things here because every element is unique and non-negative. Oh. So my first plan is just use like this exclusive or cause.
You wanna walk through an example? I don't think
Okay, so
yeah.
let me try just this one.
Yeah.
So I will go for one for the I will go like the first iteration just all the just iteration or the element in the array.
Mm-hmm.
And I also need to create create a like a rest or something.
Yep.
It will be 0. I'm not sure for now. Just mark here. Not sure. I will get through for loop first, because so the rest will be so
So 0, 0 would be 0, right?
yeah.
And then
So yeah,
0,
0 0
1 would be 1.
0 1 will be 1, and um
1, 2 would be 3, right? Because 1 is 0, 1, and 3 is, oh, sorry, 2 is 1, 0, right? And we would get 1, 1. So that's 3.
yep.
And then 5 would be
5 will
1,
be
0, 1.
0. Oh, you're so good at the byte. I just, to be honest, I just still working on.
No, that's okay.
Um,
Just trying to help you out.
um,
So
yes.
this
So,
would give us 1, 1, 0, which
mm-hmm,
is 6, right?
mm-hmm.
Which is 6. And our answer should be 3.
Actually, my thought would be like, if a number, if a number have like exclusive or in twice or fourth or kind of things, the answer would be 0, right? So like so 0. So what I thought is 0 exclusive or 0 answer would be 0, and 0 to 1 answer would be 1.
Oh, so are you saying for each number
Yeah.
you would do
So
an XOR on the array?
yeah. So what I want to thought like after the first iteration here, I will got the number. What I got is
Would
it
be it
would
wouldn't be
be
0 actually. It would be
it could be. Can I try it? Because I just it's just a plan. I'm not too much sure about the inclusive or. Can
yeah.
I
I
can I use that?
No, I don't think this would work. How about think about um so you're pretty much searching for a element, right? Finding an
Mm-hmm.
Could you maybe some kind of data structure that's good for searching and you can say, hey, check if this element exists. If not, check another one, check another one. Maybe something like that's possible.
Okay. So and can um oh can I do like yeah like maybe a list like
So maybe this will help. I think you're on the right path, but so the question said, don't modify the input array, but you can always create something.
uh
You can store that in another data structure or yeah, some other container.
oh
Yeah.
oh okay, so that is allowed. Okay, so yeah, um I think this way could be better. So I can just initiate a visit or kind of things, uh, which has the same length with the array, but the element will be all false. Because I will, so my plan is just to, uh, yeah, for, uh, like that. And I will use a mark. I will use the index to mark if the element has already been, sorry,
Mm-hmm.
it's not that. It would be plus one, I think.
No, I think that's fine. Yeah,
Right.
that's fine.
Okay. Yeah. So I will get into iteration and use the index to mark if the number have has already been appeared. So that would be like it, and if so, if the okay, so if the elements have already been appeared, I will just change the index with the element to true. So that is a first uh, um, uh, iteration, and I will use another iteration. I will use another iteration, go through the visit,
Mhm.
and just directly return the first false
Okay.
index.
Would this work?
Okay, so
Would this work? Element. So the size of visited would be equal to length of your array, right?
uh, actually, I'm not too much sure. Maybe I will use the
Yeah.
max
Yeah.
max array.
Yeah, I think that would work.
So
The only a not so
um
great thing about this is say our values were I'm typing just about say our values
mhm,
were 0, 1, right?
uh-huh.
We would create an array of size this, right?
Actually, I think the length is enough because if I cannot find the false, I can just directly return the length of. I can just directly return the length of the array because
But you can't
uh,
do you said on first step you would do this one, right? On line 44 you said visited
oh
but if our length is 3, we can't this
uh-huh.
would be out of bounds, right? Could you you know
but
hmm?
uh because just like this as example, so the value could be 3, right? Like that. So after the first iteration, it will be true, true, and false. So the answer will be the 2.
um
I don't
oh
need to.
oh got
I don't
it.
need to calculate.
So this
Yeah,
are
yeah.
you saying this is index or is that the element value? You're saying that's
Oh, yeah, yeah. It's my table. Yeah, yeah. I will say.
index.
Um. Yes, I think so.
Okay. Yeah, I think that should
Okay.
work.
Yes. Can I coding for the part?
Yeah, so let me just go through this. So you're saying this would be the index and um saying if that's out of bounds. Yep, I think this would work.
So I'll go down here.
Yeah, I
So
can
like
take out all of those. Or are you okay? You're typing there. Yeah, go ahead. Yeah.
so I will create an like array. Is the length of an array, and I will initiate a visit, which is just and um for x in array. That with it is be true.
Uh, that wouldn't work, right? Say with this input, I'm pasting on line 43. That
Yeah, yeah.
so what you said would work. What you described in your algorithm would work, but your implementation is different from what you explained.
Yeah, yeah. Yeah, maybe there is some problem here.
Let me help you out. Um,
Uh-huh.
so do you maybe want to do um, for x in array is good? Maybe, do you want to check if x is lesser than length of visited, and then you can do this. You can do this, right?
Uh-huh.
Does that make sense? So
Okay,
for
okay. Yeah, yeah. Please go ahead.
for something like 1001, you'll check my element. It's x, right? You'll check is x lesser than length of array? It is. 0 is lesser than 3.
Oh.
And if yes, then do visited of x equals true. So you'll do the same for 1, but you can't do that for this huge number because it's greater than 3, right? And then you can do what you described as step 2 in your algorithm. Did, did that help?
I just a little confused. Like, I will go like 0. So 0 is smaller than 3. So I will go 1. 1 is smaller than 3. But when I get into like the huge number, it's definitely smaller, larger than 3. But how can I get the 3? Oh, so the answer,
So that would be false, right? That would be online.
yeah.
And when you iterate through it, you'll say, oh,
Oh,
true, this is found, and this wasn't found. So this would be your answer.
so the index of the number will be answered. Oh,
Yeah.
so that's good. Okay, thank you for helping. So
So
okay, so like
you can have your code. You can have. Sorry, let me undo. That code was good. Oh, okay, never mind. Go ahead. I can't undo you. Can you hit undo?
which one? Which
Like
one?
hit Control Z or Command Z. And yeah, this is
Oh, like
yeah,
that.
yeah. Just add a check over here on line 49.
Oh, yeah, yeah, you're right. I can just make something here.
Yeah.
So, if x smaller than, uh, can I be equal? Not equal. Uh, yeah, that's enough. So one more iteration. X in y. If visit false. Uh,
That you might want.
uh,
That's I, right? On line 53 and 54, that's I.
Oh, sorry, my bad. So in this function, there will be the visits. The visits is just kind of things to mark. Does every element of the index have already been shown? So when I get into the first iteration, I need to check every element. Does every element smaller than the length? So if it's smaller than, it will be the true, else it will be false. Yeah. So I need to return the first false index.
Mhm.
Yeah, it's good.
Do you wanna
So
test run a few unit tests?
yeah, I can do kind of playing first. Yeah, I will just use the huge number.
And sorry, let me just clean
So
this up. Yeah. Yep.
thank you. So the answer will be 2.
Okay. Yep.
Yeah. 42. Uh-huh.
Line 42.
Um,
I think let's take out the comment.
oh, thank you. Um, uh, get different number.
Oh, you wanna try debugging this?
Let me think about it. It's not the iteration.
This doesn't give you the line number, but
Yeah, but I think it's kind of things from the for loop.
it's on line
So
10.
it's not. Oh yeah. Thanks.
Oh,
So if this arrangement or range, yes, it's arrangement. Okay.
awesome. So let's do. Do you have other unit tests you wanna try?
First, maybe I will try kind of simple one, just 3, 2.
Yep.
But okay, yeah, I realize that. So yeah. If there is a no false in the visit,
Yep.
the answer will be the length of. Is that right?
Great. So yep, this works. What about anything else you wanna try?
Just do a simple one. Okay, can I just run the test?
What about this?
Oh, the last one.
Or it's hard to run this because you need everything. I need to add 2, 3, 4 all the way till there. But if I did that, would your code work? What should I return? And what would your code return?
So if the example is like that, it will be
Yeah.
the answer will be 6.
Oh,
0, 1, 2.
sorry, I meant we have everything. We've got all.
Everything.
What would your
So
code return? And
that's a good question. I think my code will return like the
two
the
power
largest number.
31, right?
Uh-huh.
But if you look at the question in
It will
paragraph 2,
be
you should return undefined, right?
oh, so yeah. So interested. Assume that maximum has. Oh, so I need a corner case like if the length array larger than um yeah, but because so it will be what is will be return? I'm not sure.
I don't think you need to do it there. You need to do it on line 17, right? If you've gone through the entire thing, and if your length equals this number, that's when you return
Uh-huh.
undefined, right?
Oh, okay, gotcha. So if not, if return if a equal to else undefined. Oh, I'm not sure it will be like that. The string
Uh,
or
just
I never met it before.
just this one.
Just now.
Yeah. Uh, looks like she disconnected. Hey, yeah. So I don't want to type out this test because it's too massive, but I think it's good. Yeah.
Yeah, I understand you mean.
You wanna run your test?
Yeah. Uh, yeah, maybe I put it first because
Awesome.
awesome. Finally, oh, it seems like a not too hard question, but it always has something you need to consider.
Yeah.
Yeah, it's very interesting.
Do you wanna talk about the time-space complexity?
The time will be ON. Maybe yeah. This is a good chance I could ask a question. Like I know like the iteration will be ON, but if there is a two iteration, could I say it's a ON or ON two N? So how do you think about it?
You would still say O of n because 2 is a constant, right?
So I don't need to think about
Yeah,
just
you
ON.
yeah, in big O analysis you ignore constants because the whole idea is how does your time complexity scale with your input size? And
Mm,
even if your input is n or however large, that 2 will
mm,
always be 2, right? Because it's a constant, so you can ignore that.
mm,
Um,
cool.
so I just want to make sure this is accurate. So you've got. Okay, cool. Yeah, I think that's right. What about space complexity?
The space is also the N because we use a visit.
Awesome. Cool. Yep. Um, great. Yeah, I
You
think.
you you are so good interviewer. That
Thanks.
yeah that it looks like my experience.
So your approach is so this part we don't have to go through this. I just wanted to let you know this part.
Mm-hmm.
If you can modify the array, your algorithm is very similar. You would just do this in the visited array, and that's it. It's not exactly that. You would do it almost in similar fashion, but yeah, you would. Sorry, not visited. You would use the input array itself. But
Uh,
it's a very similar approach to what you did. I just wanted to let you know.
oh, is that? Oh, I think I is that is that means I will just if the index. Oh, so if the index is so if the element is have already so the in what can I say? So if the um
So
like
it's something
it will
like
be like the negative. I will change it to negative. Is that?
let's say our input array is 10, 1,
Mm-hmm.
0, 2,
Mm-hmm.
what I would do is, first step, I would make this, I would look at 10.
Mm-hmm.
10 is greater than the length, right? Greater than or equal
Uh,
to length, so I'll ignore it. Then I'll look at 1. 1 is lesser than length, right? And I'll put it in its position. I'll put it in its index, right? Which is 1 is already there. That's fine. Then I'll take 0. I'll see is 0 less than length it is. So I'll put it in its index. So I'll put it here. And then I'll swap it with
oh,
10. And
oh,
so I'll check this 10 once again. I'll say it's greater. So move on. I'll come to 2. And I'll say 2 is
uh-huh,
lesser than length. So I'll put 2 here, swap it with 10, and 10 is
uh-huh,
again greater, and then end of the array, right? In
uh-huh.
in your second iteration, what would you do? You would go 0. What's the value here, and what's the index? Index 0,
One.
value 0, right?
Yep.
Then 1 equals 1, great. And then 2 equals 2, great. But 3 not equals 10,
Decided to
so
10.
3 is the answer. Um,
Oh, so
this
it's
is
directly
There's something called cyclic sort. It's
cyclic.
yes, cyclic sort.
Oh,
I think so. I can't remember. Cyclic sort. Yeah, yeah, it is. Have a look at it. It's not
yeah,
exactly
that's
cyclic
interesting.
sort, but it's a similar concept. Um,
Mm-hmm.
cool. Let's do feedback, and then we can. At that point, I'll stop recording, and if you wanted to chat about anything else, wanted more feedback, happy to talk about it. So I can give feedback for you first. I think you've got the knowledge. I think you have like, you're familiar with data structures and trying to do things efficiently. So I think that's good. Um, I would say you could improve on your pace. Um, and when you do the
Mm-hmm.
algorithm, right? You were typing
Mm-hmm.
you were typing the text that you were speaking out. Don't do that. That takes up a
Mm-hmm.
lot of time, right? Um,
Oh,
instead, I would
so
say like you had say this was the example, right? I would say just
mm-hmm.
say given this example, I'll say I'll start from 0 and I'll go all the way till the end. I'll put false here, I'll put false here, I'll put false here, I'll put false here, and tell why would you put false, and that's it. And then say the second time I'll iterate through the whole thing, and sorry, these will all become true, right? um,
Mm-hmm.
and you'll say these are all true, so I'll get to the end of the array and I'll return false for n equals 4, right? And
Mm-hmm.
that would be much quicker when you come up with the algorithm rather than actually typing out the
Mm, the
algorithms.
word.
Yeah, you can save more
Yeah,
time
yeah,
there.
that's awesome.
um the other thing, I'm just curious, you're aware of hash sets, hash maps, things like that?
Mm-hmm.
You are, right? Okay. Just making sure you're aware of other data structures. Yeah,
Yeah, yeah. I just like you mentioned. I think I have kind of knowledge about them, but sometimes I don't know how to put them into like a real question.
when you're not
I just
sure when
little
you would use them, right?
yeah.
Yeah, usually think about using a hash set or hash map when you have to search for something. Um,
Uh-huh.
because it's this searching is efficient, right? Search it's bigger of one for searching. So anything that involves searching, not every case, but in
Mm-hmm.
some cases it makes a lot of sense to use them. Um,
Mm-hmm.
yeah, I'd say just practice more. You'll get a hang of it. Yeah, your communication was good. I think your programming skills are good. What else? Think about edge cases. You didn't ask any questions, but I think that's okay. This question was fairly clear, so that's okay. But
Mm-hmm.
when you write your code, think about edge cases because you didn't think about this, right? The
Mm-hmm.
what else? Yeah, I think that's it. You did a pretty good job. Just practice more. Um, and
Thank you.
yeah, cool. Any feedback for me?
I think I don't have that knowledge to just give, but I think you good because you are very quickly to understand what I'm just giving a hint.
Mhm.
Because I think at that time you do feel like stuck with something, but you just very quick realize that that's good. Because just talk about me. Sometimes when I just make some question like that, I always cannot realize so fast.
Yeah.
I Yeah, that's very good.
So that's a very tricky thing to do. It's like high risk, high reward. Because what I did, if I didn't get the
Mm-hmm.
solution right, that'll
Mm-hmm.
look really bad on me. Because the interview will think I'm cocky, I'm overconfident. Because I didn't listen to your advice and I took my own path and that
Uh-huh.
turned out to be wrong. But
Uh-huh.
in my case, I was confident. I knew I had to just tweak that logic a little bit, but so it worked out. But if it didn't, it would look really bad because from a soft skills perspective, right? It would be termed as not willing to take feedback or not. Yeah, it would be termed as not willing to take feedback, and that's not good at all, right? Because ideally, if your interviewer gives you some advice, they want to help you out, right? They're helping you,
Mm-hmm.
they're nudging you in the right direction. So if you don't listen to them, you better be right, or you're gonna get screwed. So it's like, yeah, it's high risk, high reward. Um,